Okay, guys, so the next unit is chapter 17, and it's integration, also known as anti-differentiation. Basically, it's just the reverse of differentiation. The first two units, 17a and 17b, just want you to figure this out on your own before they give you the rules. And we can kind of do that. So for example, we see this first example, dy over dx equals 3x squared. There was some function, we took the derivative of it, and we got 3x squared. Now, from your example, from your practice, you kind of say, oh, you know what? It was, where there's a 3 in front, which means the 3 came from top and the 2 came from the 3. So y equals x cubed. You can kind of run the numbers through your head. If we look at dy dx, we look at this problem here, 5 to 4, you can say, oh, you know what? We had to bring the 5 down. It came from the top, and 4 plus 1, that's where the 5 came from. And then these other ones, they're very straightforward. You can just see it, what they're doing. They're hoping that you just, fool around, figure it out, take like 5-10 minutes. We don't have time for that. And I'm going to be telling you a rule. Part D, negative 4 over x to the fifth, same idea. And you can see 1 over 2 radical x. You can imagine, how did the radical x go from positive 1/2 to negative 1/2? You see it in your head. Oh, wait a minute. If y equals x to the 1/2, the derivative is 1/2 x to the negative 1/2. That's where it comes from. You might want to think about it. So y equals dy over dx equals 10x to the fourth. That's not so straightforward. So you wonder, you know what? I know the x to the fourth came from x to the fifth. A 5 got brought down, but it ends up as a 10. So you know what? 5 times 2, that will get you to the 10. So that's the original function. Once again, I'm going to be giving you a rule for this. Now, that's 17a. 17b, they start with these problems, give 3 possible functions. The point they want to make in 17b is that, let's take a look at, 2x to the fifth. And you would say, yes, Mr. Adler, obviously the derivative of 2x to the fifth is 10x to the fourth. But you know what? What if I gave you the function 2x to the fifth plus 8? What is the derivative of that? Well, you would say, oh, you know what? That's also the derivative. What happens if I said y equals 2x to the fifth minus, pi? Well, you know what? The derivative is also that. And so this idea is when we do the integral or the anti-differentiation, we have to concern ourselves with the constant of integration. So whenever you take the integral, whenever you go backwards, you must have a c. IB will take points off. So let's look at an interesting problem. So if I ask you to do, how about we look at something basic, like dy over dx equals 5x to the fourth. And so we know from the previous example, the original function was probably like, x to the fifth, but the answer actually is x to the fifth plus c. We don't know what the c is. We're going to figure that out in chapter 17f. Right now, we can't do it. And that's basically it. Then 17c, d, and e are just basic formulas. So the general rule for integrating any x to the n is the integral of x to the n dx is 1 over n plus 1, x to the n plus 1. So the integral of x squared dx is equal to x to the third. So you add the 1, put the 3 on the bottom, and add the c. You must put the squiggly line, and you must put this dx. We'll talk about that another time. What is the integral of, x to the ninth dx? Well, you add the 1, put the 10 in the denominator, and add c. Done. Let's talk about the algebra of integrals. Let's say the integral of 7x to the fourth dx. Well, the first thing you can do is pull out the 7, x to the fourth dx. Final answer, 7x to the 5th over 5 plus c. For the sum of the integrals, you can pull out positive numbers. For this k is any real number. Pull it out so you have a basic integral, a basic polynomial. For the sum of the integral, it's just like just when you differentiate a polynomial. So, for example, the integral of x to the 3rd minus, 5x to the 4th dx is equal to, integral of x cubed minus 5x squared is simply the integral of x cubed minus the integral of 5x to the 4th. Put a dx here, put a dx there. It's very basic. Final answer, x to the 4th over 4 minus x to the 5th plus c. Some of you might say, well, do we need a C1 and a C2? No, they're both constants. You might have a C1 and a C2. We'll see that much, much later, if at all. But in general, with a polynomial, it's just one C. The differential unit, we saw that the derivative of ln of x equals 1 over x. So the integral of 1 over x dx is equal to ln of x, absolute value, plus c. In the last unit, we saw the derivative of e to the x equals e to the x. So the integral of e to the x dx is equal to e to the x plus c. In the last unit, we saw the derivative of sine of x equals cosine of x. Therefore, the integral of cosine of x dx equals sine of x plus c. And then we saw the derivative of, what did we say? How about negative cosine of x equals sine of x? So the integral of sine of x dx equals negative cosine of x plus c. Now, they gave you this last one, the tangent, just because they want to throw it in there, but don't worry about that yet. We'll figure that out. The integral of tangent x dx is equal to the ln of secant x plus c. That's it.